Hello everyone, this is a lesson in modeling with differential equations in A-level mathematics. Let's start the lesson. If you like the lesson, please subscribe so you can see more lessons like this one. Here I have an example with a differential equation that represents the rate of increase of population P of microorganisms at time t in hours, and the equation is dp over dt is equal to 3p. The initial population is size 8. Find a model for p in the form p is equal to a times the exponential to the power of 3t. So the first thing to do here is to start from the differential equation dp over dt equals 3p and find a way to solve it to find an equation of p. So the dp over dt is equal to 3p. This can be solved by separation of variables, by separating the p variables on the left and the t variables on the right hand side. And I use the inverse operation, or by cross multiplication it's possible to change the variables, and like the one you see on the right hand side, dp over 3p is equal to dt. And now you can integrate both sides, because what we try to do is to find the p. So by integrating the left hand side is 1/3 1 over p dp, and the integral of the right hand side is just 1 dt. The left hand side, the integral of 1 over p is ln p, and the right hand side, the integral of 1 dt is t plus the constant. And now I have the equation 1/3 ln p equals t plus c. It's possible here to cancel the fraction by multiplying both sides by 3. And this is what I did. I times both sides by 3 and have ln p equals 3t plus c. The next thing I did here is to use the properties of log, and I make the exponential to the power of 3t plus c is equal to the p. I use the property of a log a base b is equal to c. I can cancel the log by using a power. B to the power of c is equal to a. Here the base of ln is e, is the exponential, and this is the equation. The next thing I did, I used the algebra indices rules, and I write the exponential as e to the power of 3t times e to the power of c, which I make this the variable, the constant, the parameter a. This a represents the initial population, because if I use the t equals 0, the p is 8, so the a here need to be 8. And therefore the equation p is equal to 8, exponential 3 to the power of t is the equation of the model of the population. Find to the nearest 100, this is the second part, the size of the population when the time is 2. All I did here is to replace the t with 2. Here, so I have p equals e to the power of 6 times 8. So this is a 3227.4. And here you can see the graph, okay, of the model below. It's an exponential. The part C, find the time at which population will be 1,000 times its starting value. So 1,000 times its starting value means it's 1,000 times the 8. The starting value is the 8. So I have to have a population 8,000. And by using the exponential equations, solving exponential equation by taking the ln on both sides, it's possible to find the value of the t. And therefore the ln 1,000 is equal to 3t. So the t is equal to ln 1,000 over 3, and therefore the t equals 2.3. Here I use the properties of exponential equations. I take the ln on both sides because I have the exponential. And the last part is to find one limitation about this model. One limitation here is that since the food is the exponential function goes to infinity, which means the population will go to infinity eventually. But this is not possible under the model because food is limited and the resources also are scarce, are limited. It's not possible for any population to go to infinity. So this is one limitation you can write here by stating that the resources are scarce, so they are limited. We don't have the food available or space, so the population to go to infinity. So the exponential is just a model of, it may represent the population up to a certain time, for example, value of t, but not with very big numbers of t. And let's go to the next exercise. Here I have a cylinder. Let's check the diagram. It's a cylinder with height h and the diameter of the base is 20 meters. And of course the radius is 10 meters. And here you need to show that the dh over dt is equal to minus k cubic root of h. And let's start to analyze the problem and also simplify the problem. It says here that water flows out of the bottom of the tank through a tap at a rate of proportional to the cube root of this volume. But how do I find the dh over dt? This is one question here. How do I find the dh over dt? One way to find the dh is to use the chain rule. And the chain rule I have just summarized below. Okay, so the chain rule is the dh over dt is equal to the dv over dt times the dh over dv. The dv over dt is the change of volume over time. So I need to differentiate the v, the volume of the cylinder, and the formula for the volume of the cylinder is pi r squared times the h. So if I differentiate this one, dv over dh, I found dv over dh, and this gives you 100 pi. Because the radius is 10, so I use the radius 10 square is 100 pi h, and the dv over dh give you 100 pi, which means the dh over dp is the reciprocal, 1 over 100. And let's see another information that you have in the exercise. It says that the water flows out of the bottom, which is the volume is at a rate proportional to the cube root of the volume. Now this information allows you to prepare the dv over dt, to write the dv over dt, because they say it is a rate proportional to the cube root of the volume. And the equation that is relevant here is the one I have here. dv over dt is this one here, is minus c cubic root of v. This is what it says, is the rate proportional to the cube root of the volume, because you expect to decline the volume as time changes. You make it negative. Okay, it's not an increasing rate of change, it's a decreasing rate of change. That's why you have a negative c cubic root of v. And this, you have everything here to apply the chain rule and find the dh over dt. The dh over dt is equal to the dv over dt. Then dv over dt is minus c cubic root of v, and then dh over dv is the reciprocal of 1 over 100 pi. So by simplifying the equation and writing the equation down and simplifying, it's possible to find an expression for dh over dt. So this is what I did. This is the minus c cubic root of 100 pi h. This is the volume, cubic root of the volume, times 1 over 100 pi. Therefore, next what I did, I split the h outside of the cubed of the cubic root, because of the equation. You see, you have a cubic root of h, So I need to keep the h outside the cubic root, separate, and make the constant, the parameter minus c cubic root of 100 pi over 100p to be minus k, because it's another parameter. You may write this as a k value, and now you found an expression for the dh over dt. And this is another type of modeling. The other part of the question here is to solve the equation dh over dt. And to solve the equation, we need to think about the methods. Separation of variables is one of the methods of solving differential equations. So this one can be done using this method. So dh over, I separate the variables by taking the inverse on both sides here. So I make dh over cubic root of h. You see the variables h are on the left, and the t need to be on the right hand side. So I times by dt, and this gives you minus k dt, and now I integrated both sides. And before integrated, I need to write the h as a power. So I write the h as a power of minus 1/3, and I start the process of integration. And this gives me the integral 3 over 2h, 2 over 3, and the right hand side is minus kt plus c. The next thing to do is to times both sides by 2/3, and I have this equation. And the next thing to do is to raise both sides to the power of 3 over 2, because I want to make the power of h1. So I need to raise both sides to a power of 3 over 2, and the left hand side is h to the power of 1 is equal to, in bracket, minus 2/3 kt plus a to the power of 3 over 2. And you can make the minus 2 over 3k as another constant, as another parameter b, and the a as a. And this gives you the value of the equation of h in terms of t. This is the equation of h in terms of t. And the other part here, initially the height of the water is 27 meters, 10 minutes later the height is 8 meters. Here you have more specific numbers you can use on this equation and find the h and the h. Find the values of the constants p and q. Initial height is when the t is 0. So I use 1 point is t equals 0 and h equals 27. The other point I can use is 10, t is 10, h is 8. So this point is 10, 8. And this set of points allows you to prepare two sets of simultaneous equations you can use to find the values of the a and the b. This is what we have been asked to find on the other part, to find the values of the a and the b. So by using these points into this equation, you find the value of the a is 9 and the value of the b is 1/2. And this is this part. And the part D, find the time in minutes when the water is at the depth 1 meter. Here you need to use the value of h 1 meter and find the t as by solving the equation. And to do this, we just make the bracket to be equal to 1, because this is the value of that satisfies the equation, and therefore the t is 16 minutes. Solving this equation, you can find that it's 16 minutes. And this is another exercise. The other exercise I have here is again a differential equation with dp over dt equals kp. Initial population is 200, and we need to solve this. And we solve it using the method of separation of variables. The same way we did the previous exercise, we separate the p's in one side and the t in the other side. So the dp over p equals k dt. Then I integrate both of the sides. And the integral of the left hand side gives you the ln p, the integral of the right hand side gives you the kt plus a. After I apply the properties of logs, and the exponential to the power of kt plus a is equal to the p. I cancel the ln by taking the exponential. And I separate the exponential in two exponentials. P is equal to e to the power of kt times e to the power of a. And by using the condition t is equal to 0 and p is equal to 200, I can find the parameter a here. And the parameter a is 200. And therefore the equation p is equal to 200 exponential to the power of kt. Given that the k is 3, find the time taken for the population to go to 4,000. Here we need to solve the equation like we did before. We make the p 4,000 equals 200 times the exponential to the power of 3t. And by taking the ln on both sides, I found that t is equal to 1/3 ln to a. And you can see the graph of the function, the exponential function. The other equation I have here is dm over dt is equal to m minus m squared. And we need to find an expression for m. So to find an expression for m, we need to solve the differential equation by separating the variables. So I divided both sides by m minus m squared, and then I integrated both sides. And then I factorize the denominator as m times 1 minus m. I use the method of partial fractions here to find the integral of 1 over m bracket 1 minus m. And I separate it into fractions a over m plus b over 1 minus m. And then I times both sides by m times 1 minus m, and I have the equation you see below. Here I can find the constants a and b by using any value of m that make the bracket 0. So I use the m equals 1. So the first bracket is 0, so the b is equal to 1, and the m equals 0, so this gives you a equals 1. And since I found the constants a and b, I can use the values onto the integral now. So I can integrate these fractions that give you the ln m minus the ln 1 minus m. So the integral of the left hand side is ln m minus ln 1 minus m, and the integral of the right hand side is t plus a. The next thing to do is I use the property of ln. I make it a fraction because of the negative sign. I make it a fraction. So I have ln m over 1 minus m equals t plus a. And using the exponentials, e to the power of t plus a equals m over 1 minus m. And I separate the exponential and make it b times e to the power of t. And therefore then b here is 1 because I use the values in the exercise. T equals 0, the m is 0.5. I found the value of the b. Then b is 1. So my equation is an expression basically is m over 1 minus m equals 2. And therefore the m, by solving this equation, the m is 2/3. Okay, these are the answers. If you like the lesson, please subscribe so you can see more lessons like this in A level or GCSE topics or even higher topics. And I look forward to see you again. Thank you for watching.